All right, so for problem number 7, it says find the fourth derivative of f of x. So we got to start by doing the first derivative, and this is a chain rule. By the way, you could take this thing and write it down 4 times and FOIL it out, or use Pascal's triangle for binomial expansion and then do it four times that way, but we're just going to keep doing the chain rule over and over. So we're going to do the first derivative of x, which is going to be, chain rule says take the 4 in front, leave the inside the same, lower the power by 1, then go inside and do the derivative of the inside, and then we would want to rewrite this as 12 times 2 plus 3x to the third power. Then we're going to do the second derivative. So I'm going to take 3, okay, I'm going to take, again, chain rule. I'm going to take the outside 3 times the 12 and get 36. Remember, you don't have to do anything with the 12 because it doesn't have a variable. It's a coefficient. I'm going to leave the inside the same. Then I'm going to lower this power of 3 by 1. 3 minus 1 is 2. And then go inside and do the derivative of the inside, which is 3. Then I'm going to take 3 times 36 to simplify it. What is that, 108, I think? And there's my second derivative. Then I'm going to go in there and I'm going to do the third derivative. I'm going to take 2 times 108, leave the inside the same, lower the power by 1, and then take the derivative of the inside. So this is going to equal, let's see, 48. 3 times 2, I believe that's 648. Somebody might take their calculator and make sure I don't screw it up. And now we got one more to go. So again, you just leave your coefficient the same. That's 648, and we do the derivative of the inside, which is just 3. There's no more chain rule because it's a 1 out here, so you don't have to do that. You could have distributed 6 into there, but 3 times 648, let's see, 4 carry a 2, 12 and 2 is 14, carry a 1, 18, 19, 44. Getting close to the end of World War II. Question 9, anybody get that one right? All right, coming over here to number 8, it says, what is the 20th derivative of this? Now, it looks like we're going to have to do 20 derivatives, but I think we're going to find a pattern. Okay, so we're going to hopefully find a pattern because I sure don't want to do it a bunch of times. So the first derivative is, again, this is chain rule. So when I do chain rule, I got to do the outside part first, which is cosine, keep the inside the same, and then the derivative of the inside, which is a 2. The derivative of 2x is 2, and I can't see my heavy go. So I'm going to stick that 2 in front. So there's the first derivative. Then I do the second derivative. So the derivative of cosine is negative sine, so that's going to be a negative 2. But I'm going to put the sign here. Maybe I should. If this confuses anyone, let me know. So the derivative of 2x is 2, and I have a negative 2 times that 2 makes this negative 4. Because I had a 2 originally in the derivative. Do you guys want me to write down each step, or is this okay? How many are thumbs up with what I did? If not, I'll rewrite them. I'm looking. Is that good? I'm looking. Odds, you good? Okay, so we're going to do the third derivative. I do the third derivative. Again, I got the negative 4, and the derivative of sine is cosine, and then of 2x again, and then I take the 2 times the negative 4 gives me a negative 8 out front. And I'm going to keep going here. I'm going to do the fourth derivative, which again, I got the negative 8 in front. The derivative of cosine is negative sine of 2x times 2. So now I'm going to take the derivative of this 2x, which is 2, and it's a negative 2 times a negative 8, which gives me 16 sine 2x. And this is very much close back to where we started right here. Okay, so I'm going to do one more, but I'm going to put a different color because I think it starts repeating a little bit. So when I do this one right here, I almost wish I'd have done this a different way, but anyway. So the derivative of sine is cosine x of 2x, and then I'm going to take 2 times 16 gives me 32. Now if I look at this one and I look at this one, they're very similar except for the number in front, right? So it looks like to me they're going to start repeating every fourth time. Does that make sense to you? Every fourth time? They're going to be the same thing, right? So what that tells me is that when I get to 20, that goes into 4 goes into 20 with no remainder. So that means I'm going to end up, when I get to the 20th one, if I keep this pattern going, I'm going to end up with a sine of 2x, because that would be a fourth, that's a multiple of 4. Because every fourth one's going to repeat back to the first one. Okay? Now, let's look and see about our number in front. Well, we start with this. This is the first derivative. I think that's 2 to the first, isn't it?
Yeah.
And I think 4 is 2 to the second. I think 8 is 2 to the third when I did the third derivative. I think this is 2 to the fourth on the fourth derivative. And by the way, I hope you also notice that the middle two are negatives every time. So this next one would have been a negative. Maybe I should have done one more. Do you want me to do another one? Okay. So anyway, this is going to be 2 to the 20th in front. So that right there is going to be our answer. And you want to write that 2 to the 20th as a number, you can, but I'm not going to. Question on that? So those, yeah.
So it's positive because it's a sine.
Because it's a multiple of 4, and every fourth one is going to be a positive.
Oh, okay.
Okay. I believe, maybe we should do a couple more and make sure I didn't screw that up, but I'm pretty sure that's right. This next one here, y to the sixth derivative. I'll have to put these in parentheses. I think they put these in parentheses when they write them like that. So the sixth derivative, let's see, this would be a negative 64 sine 2x. I'm going to go on down a little further and do the seventh down here. The seventh derivative is going to be a negative 128 cosine 2x. And then we get back to this one, and we get back to a positive again, right? That'd be what, 256?
Yep.
We'd have sine of 2x. So again, you see every 4 is going to go back to the positive sine of 2x. And that 20 is divisible by 4, so it'd be the positive 2x sine of 2x again. And so whatever that is. Okay?
Will they accept answers like that on the AP exam, or will we have to actually write out two?
They will accept this. Now, this would probably be a multiple choice one, and if they did not want it to be if this was a multiple choice and they didn't want 2 to the 20th, they would actually let you use a calculator to get 2 to the 20th. I don't think they're going to make you multiply 2 times itself 20 times. All right, so that's 8. Now we got number 9. So number 9, I cannot see that number. What is the little number with the D?
Y equals x in the.
No, I can see that one. What's the
An N.
N? So we are looking for a pattern again. So we're saying if we keep doing this over and over and over and over again, what's the nth one going to be? So we need to look for a pattern. So I think we're going to use product rule, if I'm not mistaken. So when we do product rule, y prime is going to equal the first term times the derivative of the second term plus the second term times the derivative of the first term, which is 1. So I'm going to rewrite this a different way over here. So I'm going to factor out an e to the x. I'm not really sure what this is going to end up looking like yet, but I want to look at both things. I'm not going to do product rule with this one over here. I'm going to go ahead and I think I'm going to do this one again. So I'm going to do the second derivative. I could do product rule over here, but let's see what we get when we do this one again. So this is going to be, the derivative of this is going to be x e to the x plus e to the x. That's going to be the derivative of this because that's the same as this, right? Those are the same thing, so I know I'm going to get this out of that. And then when I do the derivative of that e to the x, I get this e to the x. So when I do this one, that looks like I'm going to have, I'm going to rewrite this as x e to the x plus 2e to the x. Because those are like terms right here. So it looks like to me that's going to equal e to the x times x plus 2. Now I've got a good idea right now what the answer is going to be. Do you? So if I do, I'm going to do one more and see if it looks like this same thing. I'm going to do the derivative of this one. Okay, so I know the derivative of this first part is exactly the same as this first one up here. So that's x e to the x plus e to the x when I do product rule for this part. And then the derivative of this is also 2e to the x right there. So it looks like that's x e to the x plus 3 e to the x, because those two are like terms. So 1 e to the x and 2. So this is going to be e to the x times x plus 3. So do you think we've done enough to see a pattern? So if I'm going to do, and maybe I should have been doing dy over dx as I went here. Maybe I should have written them like that. So I'm going to rewrite these so it looks like that. So dy dx, and over here would be d2y dx. And down here would be d3y dx. Third. And then so if I'm going to do d to the n y dx to the n. I hope we see where these 3's are going over here, right? It's going to be an e to the x times x plus n. Question? Okay, I think we're going to stop there and you guys can work on this. The video is on the Canvas page. And I do not think there's a quiz on this one. I'm pretty sure there's no quiz on this one. I'll look.